and welcome, and in this video we are going to be talking about finding zeros of polynomial functions. You can also think about this as just solving polynomial equations because sometimes they're kind of interchanged. So, finding zeros of polynomial functions such as this one. It's really just solving a polynomial equation. What we do is we set it equal to 0 and solve. So I'm going to go ahead and set this equal to 0 and solve. And now, the problems that we're going to be covering today are all going to be factorable. So all of our factoring methods that we've been covering so far are going to be used here, and as such, I'm not going to go through the factoring step by step here. Now, for this particular problem, all we have to do is factor by grouping. So I'm going to go ahead and factor this by grouping. And there we have it. We have our three zeros here. We ended up getting zeros of 1/2, -1/2, as well as -3. Now, there is something that I want to point out here, and this also comes into play a lot when we start talking about polynomial functions. Notice that for this particular function, the degree of the function was 3. The degree of the function was 3, and we ended up getting 3 zeros. Not only that, we ended up getting 3 factors. I can write this function in what's called factored form, which is just a product of all of its factors. So I'm going to go ahead and rewrite this, as we can see here. So as we see, the degree was 3. We ended up with 3 zeros, and we ended up with 3 linear factors. This can all be attributed to what's called the fundamental theorem of algebra. Now, the fundamental theorem of algebra is a little bit confusing when you just read it. I'm going to go ahead and break down what it actually kind of means in our context. Now, the fundamental theorem of algebra states that if you have a polynomial function of degree n, you have at least one complex zero. That doesn't seem very useful, but a lot of its consequences actually are particularly useful. One of the consequences is that the degree of the polynomial function is going to be the same as the number of zeros you find. So notice I could have determined right away that, hey, this polynomial function has a degree of 3, which means that we're going to end up with 3 zeros. Another consequence is that the number of linear factors is actually also going to be equal to the degree of the polynomial function. So once again, we got a degree of 3, so we ended up with 3 linear factors, and that is always going to be the case. So now that we know that, we can actually look at the degree of a polynomial function and automatically determine how many solutions we're going to get, or how many zeros we're going to get, or how many roots we get. All those mean the exact same thing. And remember, zeros, roots, solutions, they all represent x-intercepts graphically speaking. So that's going to come in very handy once we start graphing polynomial functions. But let's go ahead and take a look at a new problem. So let's take a look at this problem here. Once again, we're going to go ahead and find out how many zeros there are, but first things first, I'm going to make note that the degree of this function is 3, so we should end up with 3 zeros. Now, to find those zeros, we have to set this equal to 0 and solve, so let's go ahead and do that. So, this was once again a factor by grouping problem. Don't think that's only going to be the way. All the methods that we have learned how to factor are going to be used. Grouping, factoring trinomials, greatest common factor, and the sum of difference of cubes, as well as difference of squares. As you can see, we've been using difference of squares quite a bit here. Now, something interesting actually ended up happening. Notice the degree is 3. And we do end up with 3 linear factors. And one thing though, and we do end up with 3 zeros, but 4 actually happens twice. So we do have a 0 of -4, but we actually have 4 happening twice. And that actually represents something particularly special in mathematics, and this is what we call a multiplicity. A multiplicity just means that a certain 0 occurs more than once. And in this particular case, the 0, 4 happened twice. So I would actually say zeros of -4 and 4 with a multiplicity of 2. And we can also determine that because the factor happened twice. So another way I can write x minus 4 times x minus 4 is x minus 4 quantity squared. So notice I can see right there that it is actually happening twice. This would be the factored form of this polynomial. So yes, the degree is 3, and we did technically end up with 3 zeros. It's just that only 2 of them are unique. Now, multiplicity is a big deal because once we get the graphing, that's going to hold a particularly special value. If a 0 occurs an even number of times, it actually doesn't cross the x-axis at that point. It actually touches the x-axis and bounces back in the opposite direction. So that is particularly important to make note of. So if a 0 occurs twice or 4 times, 8 times, 22 times, it won't cross the x-axis there. It'll actually touch the x-axis and bounce back in the opposite direction. However, if a 0 occurs an odd number of times, so say once, or even 3 times, or 7 times, or 11 times, then it is going to cross the x-axis like it normally would. We'll get to that a little bit later once we start talking about graphing, but it is important to make sure that you do write with a multiplicity of 2. If the 0 happened 5 times, I would say with a multiplicity of 5, and so on and so on and so on. So let's take a look at one last problem. Okay, so let's take a look at this last problem. Right away, I recognize that the degree of this particular function is 4, so I'm actually going to end up with 4 zeros, okay? And remember, all we have to do is we have to set this equal to 0, we have to set this equal to 0 and solve, and we're going to be solving by factoring. I'm going to go ahead and speed through this. I'll kind of explain a little bit afterwards, but all you got to do is factor like we've been doing this whole time. Now from here, we actually can go ahead and find our zeros. So notice the first thing you had to do was take out a greatest common factor of 2x, and then it was a sum of cubes, which is one of the newest methods that we have learned so far. Now from here, we can go ahead and set each factor equal to 0, 2x equals 0, x plus 2 equals 0, and you could try factoring this trinomial, but remember, whenever you use the sum or difference of cubes, if you do it correctly, that will actually not be factorable. So right away, we could see that one of our zeros would be 0, one of our zeros would be -2, so 0 and -2. But what would these two zeros be? Well, we can't factor it, so remember, don't forget the quadratic formula, or complete in a square. Remember, those are two ways that we can solve any quadratic equation. So I'm going to go ahead and use complete in a square. You probably know I prefer complete in a square as opposed to the quadratic formula. You can go ahead and use a quadratic formula. You would get the exact same answer. So I'm going to go ahead and do that real quick. And those would be our final two answers. Now, if you use a quadratic formula, you would get the exact same answer. I just went ahead and completed a square. And notice that both of these are actually imaginary. We get two complex conjugate solutions. Oh, I realize that I just kind of ran out of a little bit of room right there. But we end up getting 1 plus or minus I root 3. So those are our two remaining zeros. Now, remember, zeros are x-intercepts on the graph, but actually only real zeros are x-intercepts on the graph. So if you were to graph this function, you would actually only see 2 of the 4 zeros. That doesn't mean that we don't have to find the complex conjugate zeros or the imaginary zeros. You still have to, it's just that you won't actually see them on a graph. But notice, finding zeros of polynomial functions is the same as just factoring and setting the factors equal to 0. I hope this video was helpful. If there's any questions, please feel free to let me know. And I look forward to seeing you guys in the next video.